Now, let's take a look at this simple but a very beautiful geometry problem from 2025 AMI 2 paper. This is problem 1 of this particular paper. So let's first read this. Let's try to draw the diagram. So we have 6 points A, B, C, D, E and F. They lie on a straight line in that particular order. Suppose that G is a point not on the line such that AC is 26, BD is 22, CE is 31, DF is 33, AF is 73, CG is 40 and DG is 30. Then we have to figure out the area of triangle BGE. Now first let's try to visualize the figure. So we have 6 points A, B, C, D, F. They are lying on a straight line in that particular order. So let's take this to be that straight line, and then we have the following points, right? So A, B, C, D, E and F, these lie on the same straight line, while G is a point not lying on that particular straight line, right? And now basically we can actually go ahead and join all these A, B, C, D, E, F points with this particular point G, like this. Now we have a few relations, basically the length of few line segments also. So to represent this, for example, we have the value of AC as 26, right? So what we can actually do in this, we can actually break down all these into different line segments, for example, AC, BC, CD, DE, EF respectively, right? So for example, if I actually write the length of AB as let's say A, BC as let's say small b, CD as C, DE as D, and finally EF as E. So I can actually go ahead and write down all the relations as well. So for example, AC is 26. So that actually means A plus B has got to be 26. A plus B, this is to be 26. Then BD is 22. So BD is 22. That means B plus C has to be 22. B plus C has to be 22. Let's just first quickly write down all the relations without worrying too much anything about it, right? So BD is 22. So B plus C becomes 22. CE is 31. So C is 31. That is C plus D has got to be 31. Then DF is 33. So D to F is 33. So that is D plus E becoming 33. And then we have AF as 73. So A to F is 73. So that means all these values add up to get a 73. So A plus B plus C plus D plus E. A plus B plus C plus D plus E. And this turns out to be a 73. Nice. And then we have the values of CG as 40. So C2G, this is 40. And D2G is 30. So D2G, this has got to be a 30. Now, what do I have essentially to figure out? We have to find the area of this triangle, that is BGE. So triangle BGE, this triangle's area I have to figure out. So what we can actually do is first focus on this particular triangle, that is triangle CGD. Now, why am I actually focusing on this particular triangle? Because I already know the exact length of two of its line segments, right? Two of its sides. So this is 40, this is 30. So I'll actually go ahead and try to figure out the value of this. That is, I need the value for C. Once I have the value of this particular triangle, then actually I can use the part where I can actually say, because this triangle BGE and triangle CGD, these two triangles lie on the common base, and because they have a common base and the common vertex, so essentially both their heights will be same. So from the triangles theorem, basic theorem, whenever two triangles lie on a common base and then they have a common height, the area of these particular two triangles is the ratio, right? The ratio of areas of these two triangles is the ratio of areas of the bases. So simply I'll have to find the ratio of their bases. So for that also I'll simply need the values of B, C, D individually maybe. So that will be the process of this particular problem. So let's try to figure out the values of these individual variables first. So this can actually be done using observation. So if I observe the combination of values given A, B, B, C, C, D, D, and then we have A, B, C, D, E. So I can actually quickly observe, for example, I have A plus B as 26. And then if I see, I also have C plus D as 31. So A plus B is 26 C plus D is 31. So that way I can actually figure out E first to begin with. Right, to begin with, I can actually go ahead and figure out the value of E. So AB is 26, CD is 31. So these two values add up to what? 57. Now, because these two values add up to a 57, E has got to be a 16. So that is the first major breakthrough. I have the value of E as 16. And now if we look at the pattern of these equations, because E is 16, I can also say the value for D has got to be what? 33 minus 16, 17. Because D is 17, I can actually plug in the value of D in this equation and get the value of C as 31 minus 17, 14. Because I have the value of C as 14, so I can actually plug in this back into the second equation and then say the value of B would turn out to be a 22 minus 14, that would be 8. And similarly, I can actually also figure out the value of A. Maybe it might not be needed, but let's do this for clarity purposes. So for example, if I have the value of B as 8, I can also figure out the value of A as 26 minus 8, and that would be 18. Right? So I have all the values. Now, if we look at this particular triangle, that is triangle CGD, I now have all the three sides. This is 40, this is 30, and now I have the value for C as 14. So I can actually go ahead and figure out the area of this triangle first. Now, how do I figure out the area of this particular triangle? So we can again use a theorem of geometry, and that is basically called Heron's theorem or Heron's formula, right? Now, because I have the three sides, Heron's formula says that area of this particular triangle, area of triangle will be equal to square root of S minus A, S minus B, and S minus C. What is S here? S is the semi-perimeter of this particular triangle. So perimeter would be the three sides added up. So 40, 30 and 14 would be 70 and 14, 84. So 84 divided by 2 because we need the semi-perimeter. So it is half of the perimeter. So for perimeter was 84. So 84 divided by 2, 41. So this has got to be 40, sorry, 42. And then what are these A, B, C? The sides, all the three sides. So this is A, let's say this is B, and then this becomes C, right? So what do we have? 42 minus 40, so that will be 2. 42 minus 30, that will be 12. And 42 minus 14, so that will be 28. Now I have to figure out the square root of this particular expression. Now what I can actually do is break this down. So I can actually say 42 will become 6 into 7. 2, I'll keep it as 2. 12, I can actually break this down into 2 into 6 because I also have one more 6. So I can take out 1 6 from here, right? So 12 is 2 into 6, and then 28 becomes 4 into 7, right? 4 into 7. Now I can actually easily see from here also that I can take 1 6 out from the square root. Then I can also take 1 7 out from the square root. So I can actually take out 1 2 from the square root, and then from this 4 I can take out 2 because this 4 is nothing but 2 into 2, so I can actually take out 1 2. So what is the area now this of this particular triangle CGD? So this is 42 into 4, right? We'll do it over here. So this has got to be 7 6 42 into 2 2 4, right? So 4 to 8, 168 square units will be the area of this particular triangle CGD. Now finally, the final point we have to do is realizing again, that is triangle BGE, area of triangle BGE, and area of triangle CGD. These two triangle will have the ratio of their areas in the same ratio as of their sides, because these two triangle lie on a common base, and these two eventually will have the same altitude or height when dropped from G. So the ratio of areas will be the ratio of their bases. Now, what are the ratio of bases? So BGE's base will be B2E. Now B2E will be B plus C plus D. So B plus C plus D. So that will be 8 plus 14 plus 17. So that is 31 plus 8, 39. Now CGD's base will obviously be this 14. Now I know already the area of this particular triangle, that is triangle CGD, which we have just figured out, that is 168. So what will be the area of this triangle BGE? This will be multiplied by 39 by 14. So 168 multiplied by 39 divided by 14. So what do we have from here? 14, 1, 14, 14 to 28. And then finally 12 into 39. So this is 360 and 12, 9, 108. So that will eventually give me what? 468. And that is the answer to this particular problem. Wonderful problem. Thank you.